silicon is eating the software. This is a term I devised a couple of years back to really signify a change where we are moving from software based or cloud based system to more and more components and platforms, including application going in a piece of silicon. And I was so very true and correct. Today, we have more and more systems that are built in a SoC or a system on chip. Hello, everyone. My name is Aditya. I'm the founder of Skive. I think we are a San Francisco and London-based company building machines that feel. Specifically, we are building the heart of the robot, making robots much more human as opposed to superhuman. This is our weekly tech talk focused on AI. And today we'll be covering the intersection of AI and silicon or semiconductor. And I do have a few questions that I will be covering. And before we go in deep into that, let me give you a little bit of introduction about what I just talked about, which is silicon is eating the software. And in context of artificial intelligence, a couple of years back, it may not have been feasible for a small company like ours or a big company, for example, Facebook, Tesla, to even think about building their own silicon for their internal application or for their external systems. Tesla recently ditched NVIDIA, and now they are using their own custom built silicon. Apple moved away from Intel, and now they have the A12 and A13 Bionic chip, which is an ARM-based cores. It's actually the same architecture that's being used in the Mars rover today, as well as the same and similar components that's used on your iPhone. Facebook is also looking at building their own silicon to power their data centers. Why is this happening and why is it happening now? So it started about 2-3 years back when it was much more feasible for a small company like ours or a big company like even Facebook and Tesla or Apple a couple of years back to work directly with the foundry and build a silicon. And the best foundry I can think of today is actually TSMC. Apple, Facebook, Tesla are all customers of TMC, including NVIDIA. And to some extent, this also happened because companies like Intel and AMD were a little bit behind in terms of their fabrication capability, Intel specifically, and also Samsung. Their fabrication facilities are not up to the mark. And that was one of the reasons for these bigger vendors to say, okay, let's go with TSMC. And more important, TSMC was willing to get some of these customers and to build their own, to build custom silicon. And second thing was the technology itself, that it made much more and more feasible because of the cost going down to go to a specialized architecture, a specialized system on chip, which includes everything. With that introduction, let's go to your questions. Our first question is explain the phrase silicon is eating the software. As I mentioned to you before, this is something I devised about 2-3 years back, and it was really driven by both what we internally are doing, which is our vision to have heart of the robot in a small silicon. Think about it as that AGI on a piece of silicon, and you put that chip into a level 5 autonomous car, and voila, your car could actually feel, it will have its own personality. Or you can put that in a jet or in a robot companion for the elderly. It was possible not just internally at my company, but to many more startups and bigger companies, because you could very easily, using tools from companies like Cadence and Synopsys, very easily able to build, design, and fabricate all the components that you need to run an application or run a system on a simple piece of silicon. And that's what happened in the last 2 3 years, that more and more chips are becoming specialized, and more they are becoming specialized for one application or one use case. Tesla is autonomous driving. Facebook, it would be for optimizing something like your like, or for a company like Google, who have TPU version 1, 2, and 3. It could be to run their workloads for search much, much, much better. And that's what silicon is eating the software came from. This, to some extent, is a continuation of what one of the big venture capitalists here in the Valley said, which is software is eating the world. And that is actually true and still true, but what is even better than that is silicon is eating the software. Second question is, why is every company building customized chip for their products these days? And that's a very valid question. It holds for both startups as well as for bigger companies. So if you think about startups in context of artificial intelligence, we want to do more and more of this work in a much more optimized way, because there's lots and lots of data coming in. For example, advanced AI system based on deep learning. We're doing training on a very, very large scale. You need as much efficiency and as much power optimization as possible. And that is only available when you build your own customized chips. And it's not a surprise that there are a dozen well-known startups who have some sort of customized ASIC for artificial intelligence workload. Novamind, for example, they always have inheriting other chips that require tensors to be unfolded into dimensional matrix. Another company that comes into mind is Celebras, which has 400,000 cores in a piece of silicon, and they promise close to 9 petabytes per second of memory bandwidth. And that was because we have more and more data and our processing is more and more. So you really need to have all those cores much, much closer together to have as least latency as possible. They also optimize linear algebra cores where you don't have to divide or multiply by 0. Mystic is another company that comes into mind, which is low power, low area IPU. And the interesting thing they do is that they do matrix multiplication, that is the basis and the basics of deep learning on a chip in analog, and that really reduces the latency. It increases the power utilization. So essentially it reduces the power per computation. Samanoma is another great example where they optimize everything from the algorithm all the way to the silicon. So they have actually developed a system that is flexible, efficient, and scalable, and optimized for data flow from algorithm to system. They are still specialized chips, but they're very specifically built for artificial intelligence. Intel, which is on the bigger company side, acquired a company called Nirvana, and they came up with this Intel NLPL, which does learning and to some extent training on chip in a very memory efficient way. And they do it because now they have much more and more memory inbuilt in one chip. That's one level of optimization and customized silicon. Then second level is what I already talked about, where the companies like Facebook or Tesla are building, or Apple, actually Apple is the best example here. They're building silicon which is very specific to their use case. It's not for external consumption, it's very specific for their use case. It could be autonomous driving, it could be a silicon that is only meant for your iPhone. And that means that now you could reduce the latency, have better service and better systems and more security. The next question is, why will one want to build a SoC versus building a software platform? For people who don't know SoC is system on chip, where you have multiple components built in a silicon. So if you think about a system, you could have, you will need CPUs, you may need GPUs, you may need memory, you may need some computer vision capabilities. Currently, what you do is that you will have GPUs, a computer for that, you will have CPUs, a different system for that, a server for that, you will have some computer vision libraries running on a separate system, and they will be interconnected through Ethernet, for example, or they'll be on the network. On SoC, you condense all these parts into one single silicon. It's a system on chip. There are many examples of it. A12 Bionic from Apple is a great example of that, which has 64-bit ARM cores and a bunch of other things, including a neural network engine on the same silicon. Why would you want to do that? The first thing is now that everything is very close together, you could optimize it really, really well. Your latency is less. And more important, it's a small form factor that could go into your iPhone or could go into an edge device. It is also will be low power. And lastly, it's more secure. You cannot reverse engineer that system because everything is in a piece of silicon. Well, there are ways to eavesdrop in a silicon instead of silicon as well, but it's not that easy. But it's much, much more easier to do it on a software. And we'll take one more question. The last question will be, who will win? AI chips from startups or big companies like Intel, AMD, and others will dominate this area? That's a very good question. And I will give you two examples. So one is from a big company. Let's pick Intel. Intel, to some extent, the last 2 to 3 years have fallen behind drastically in terms of their fab capabilities. They even announced that they will reduce the fabs a year back. They were also not doing good on the management side of things. But most recently, we have seen signs that they are again going back to the core of building silicon in-house, investing in fabs. So things may actually change. And part of the reason being that when you are trying to design something which is for the masses, you have to have your costs very, very, very down. And that's probably one of the big reasons why Intel was not doing well. And they also were facing a lot of competition from companies like Samsung and TSMC. TSMC, for example, is subsidized by the government in that region. That's not the case with Intel, for example. So they have valid reasons, but they are in the right direction. On the flip side, on the small company side, I mentioned 4 companies, Novumine, Celebras, Mystic, and Samanova. They are doing decently well, but they still don't have the scale to actually expand. And what may happen probably is that none of these companies may actually exist in the next 2 to 3 years, and because they will either go down, because these are still general purpose chips. And why would somebody want to go with a niche vertical semiconductor vendor, which may or may not exist in 2 to 3 years, even if they have a better technology, as opposed to somebody big who we know that will exist, like Intel or AMD or NVIDIA. And I think that's the hustle and bustle in the semiconductor market right now, that the cost basis is not the real issue. The real issue is the reliability and the reputation of a specific vendor. Because when you're trying to purchase silicon, it's not something that you can rip and replace every year. So for a big enterprise customer, you need to really think about, will this company exist? Will we be able to use the same workloads on their same processor, maybe a different version without any change? And that's one of the issues with these smaller vendors like Celebras, Mystic, Novamind, Samanova, and there are many, many, many more actually. Intel, in that respect, Intel or AMD and NVIDIA, as well as Google, when it comes to TPUs, is a great option in that. So far, it seems that when it comes to these companies being a vendor or a supplier to other companies, the bigger companies are still a better bet, like Intel, AMD, or NVIDIA. They may not have the best performance, but that is okay. But at the same time, what I see happening is more and more enterprises who are customers of these companies, small like Mystic or big like Intel or Nvidia, will move towards building their own silicon, and that time it will probably be easier for some of them to acquire some of these smaller companies. And even some of the bigger companies like Intel or Indu to acquire some of the smaller companies, and that will make it feasible for some of these dedicated architectures to actually exist, especially on the AI side. Bottom line, I think at least in the next couple of years, I don't see Intel, AMD, or Nvidia going anywhere else, and that's probably what you want to bet, as opposed to some of these niche vendors that have AI-specific processors like Novamind, Cerebras, Mystic, Samanova, and others. Thanks, folks. This is all for today. If you have any questions, please feel to reach out. I could directly be reached at Aditya at Skive. And just as a reminder, this is also live on Clubhouse. Please feel free to follow me there, and I will see you next week. Bye bye.